Today, Elon Musk definitely took a sigh of relief as one of SpaceX's crucial missions became a success, and especially after the recent explosion of Starship, this success has brought some happiness to SpaceX and Musk.
That stunning launch, a new American rocket built not by NASA, but by billionaire entrepreneur Elon Musk.
SpaceX launched its powerful Falcon Heavy rocket for the 6th time ever on April 30th, sending 3 satellites to distant geostationary orbit. This mission was aborted at the last minute on April 28, and SpaceX didn't state any reason for the abort. However, the Falcon Heavy lifted off from NASA's Kennedy Space Center in Florida, carrying 3 satellites aloft after days of delay. This mission was a long but successful one. The 3 satellites were deployed as planned over a 13-minute stretch beginning about 4.5 hours after liftoff, SpaceX confirmed via Twitter the next day of launch. The primary payload on this mission was Viasat-3 Americas, a 14,000-pound, 6,400-kilogram broadband satellite that will be operated by California-based Viasat. Viasat-3 is expected to be the world's highest-capacity satellite and will be the largest all-electric satellite ever to be launched, SpaceX propulsion engineer Atticus Federa said shortly before liftoff during the company's launch webcast. The second satellite that flew was Arcturus, a communications craft that will be operated by San Francisco-based Astranis Space Technologies. Although it only weighs 300 kilograms, 660 pounds, the mighty communications satellite has the ability to provide data throughput up to 7.5 gigabits per second for Alaska and the surrounding region. The third payload was GS-1, a CubeSat that will be operated by Washington-based Gravity Space. GS-1's primary mission involves providing communications for Internet of Things applications, though it will do some other things in orbit as well. The spacecraft is also designed to provide orbital slot reservation services, (BIU), around the geosynchronous arc. The spacecraft features 3 wideband frequency bands. The spacecraft also carried an imaging system capable of imaging both the Earth and spatial bodies, as well as an experimental rendezvous and docking payload. The Falcon Heavy consists of 3 strapped-together first stages of SpaceX's workhorse Falcon 9 rocket. The central booster is topped with an upper stage and the payload. Falcon Heavy debuted in February 2018 with a memorable test flight that sent SpaceX founder and CEO Elon Musk's red Tesla Roadster into orbit around the Sun with Starman, a spacesuit-clad mannequin, at the wheel. The burly rocket has now flown 5 more times since then, including twice in 2023. This year's other mission, called USSF-67, was a mission for the U.S. Space Force that launched in January. The Falcon Heavy's 3 first-stage boosters are designed to be reusable. However, none of the boosters were recovered on this mission because they didn't have enough fuel left over to maneuver themselves safely back to Earth for a vertical touchdown after sending such a heavy load to such a distant orbit. Geostationary orbit lies about 22,200 miles, or 35,700 kilometers, from Earth. Is the Falcon Heavy SpaceX's most powerful rocket? For more than 5 years, the Falcon Heavy was SpaceX's most powerful rocket, but the company's gigantic Starship vehicle took that title with its debut liftoff on April 20th, a test flight that reached a maximum altitude of 24 miles, 39 kilometers, and ended in a commanded explosion high above the Gulf of Mexico for safety's sake. Starship's 33 first-stage Raptor engines generate 16.7 million pounds of thrust at liftoff, according to SpaceX. That's more than 3 times more than the Falcon Heavy produces, and nearly twice as much as the second-place vehicle, NASA's Space Launch System Mega Rocket. But it exploded in midair. Falcon Heavy safely deploying these 3 satellites is a success that SpaceX is celebrating at the moment. This marks a significant milestone for the company, as it proves the reliability and capability of their rockets. However, SpaceX must continue to innovate and improve its technology to ensure the safe deployment of future payloads.